So you might be tired of hearing this, AI, AI, AI. I go home, I talk to my kids about AI, and my wife about AI. So I've come here, they said, get out of the house, go and talk about AI to somebody else. But yeah, it's tiring. But the fact is that it is collapsing the cost of producing code, which is like a little scary as an engineer and as a developer. So that's what I wanted to talk to you about tonight. That we can generate more lines of code faster than ever before. What could possibly go wrong? More people building, more people making tools, more apps coming out, more products, more everything. And while I'm all for the democratization of technology, and that is a good thing, I wonder how many of you have seen this, the developer keyboard of the future. It also means that we're in danger of creating maybe the worst software that we've ever seen. And if you take everything wrong with the way that we make software today, I doubt anybody in this room would say, yeah, let's scale that. Our problems aren't new. We often start with little or no plan, or we think it's a good plan, and then we start and we realize it actually wasn't a plan. In teams that are shipping software, quality is often fighting for oxygen, right? We've got to ship, we'll fix it later, and we accrue tech debt, and we're going to fix it later. And we sort of prize, maybe not as individuals, but as in the teams and the companies and the businesses that we build, we prize output over coherence, right? Because you can always fix it later, and software is malleable, and what's the big deal? But out of that, we start to compound this sort of weak shared understanding of what it is that we're building. Because as you were working on the code in the project that you were working on this week, you probably know some of the edges that you might have done a little bit differently, or you'll come back to fix, but how many of the people on your team know that, right? So I'm going to shift a little bit and talk. I think here, Andrew Karpathy's framing, I think, is very useful to kind of put a frame around what we're experiencing. And he talks about software 1.0, 2.0, and 3.0, and we are like way into software 3.0 now. Software 1.0 is traditional coding. It's probably what we still do day to day. We reason about the code. We write explicit instructions. It's human written. It's deterministic. Over the last, count them, maybe 10 years or so, software 2.0 came along, training neural networks on patterns. How they work inside is a little bit opaque to us. We can just judge on the inputs and the outputs, and they consume very large data sets. I've not met a whole lot of neural net professionals, ML professionals who do this for a living myself, because we're largely operating in software 1.0, where we're writing the code and we're designing and building apps that run. But we've suddenly been thrust into this world of software 3.0, where we can prompt one of these amazing neural nets, one of these LLMs, and they can kind of do our job for us. And that's the core of what I want to talk about today. But before we go any further, I am aware, and I experience this daily, that there's a lot of FUD, if you're familiar with that term, in the industry. New terms, new companies, new tools. Every single day, every hour, there's something new coming out, and it's very, very overwhelming to sort of reason about it and understand, what is everybody talking about? Is this new thing really going to replace the thing that I only heard about yesterday or last week? Or is it just is this just a flash in the pan kind of marketing stunt? And so the important thing I want to convey is it's actually not magic, it's a machine. And I think that everybody in this room is very, very well placed to understand how machines work. If it's a machine, we can reason about it. So I want to start with a few core concepts, build them up, and I think by the end of it, you'll be able to take away a solid understanding of what everybody's talking about, so you can form your own opinions next time you hear tomorrow afternoon that some new thing has come out that's going to obliterate everything from the past. So down at the bottom, really basic, we've got providers, right? Providers like OpenAI, Anthropic, Google, Apple. There's a handful of them. There are many more, too many to fit on a slide. But these providers provide, generate, build, train models. And their models, GPT, Opus, Gemini, Apple's foundation models, and so forth, are the models that they vend. So OpenAI has GPT, Anthropic has Opus, Sonnet, Google has Gemini. I think just across the board, it's just all more Gemini as far as the eye can see. And Apple has foundation models. And I think it's useful just to point that out, because when you hear that OpenAI has come out with a new codex, well, what's a codex, right? It's a model, it's a product. So at the products level, you have ChatGPT that uses the GPT model by OpenAI, and so on and so forth. I'll call out the one to the end, APIs, so you can interact with these models either through products, like Claude Desktop, or through APIs. If you're a developer, you can call them. And we're here. We're largely consuming this stack and building on top of it. Something I think is really important to understand the difference between is model and inference. So the model is the pre-baked machine, if you like, trained neural network, trained on patterns, takes a lot of energy, takes a lot of resources, takes a lot of data. Some of it is not all your data that they train on, but your mileage may vary. But you can think of the model as the brain, and when you make a request onto the model, what that model does is it runs inference. It infers what the next best piece of the answer is going to be. And that's the act of thinking. There's a lot of talk about, this AI is going to steal my information, how private are my API requests, so on and so forth. And it's important to know that when you run inference on a model, you're not training the model directly. Those two things are separate. Is your data getting siphoned to a data lake and then analyzed later? Yeah, sure, but it's not training the model directly. And if we look a little bit deeper, and this is going to get a little technical, so bear with me, but then we're going to come back out of it. And if we look at how these models actually operate, is they work on embeddings. And what an embedding basically is, and I tried to kind of explain this as simply as possible, is if you think of assigning every word in the dictionary to a number, then you could say, you could form relationships between the different words. But of course, if you only assign one number to one word, sometimes words have multiple meanings. So you assign a set of words, a vector. And if you assign a vector to a word, then you could do neat mathematical things with it, like calculate distance and correlation between vectors. And that's how we get semantic search. And an LLM can understand, in air quotes, that the word architecture is closer to design, but not banana. At the simplest level, the user asks a question, makes a request to the model, it runs inference, and the model generates a response. I'm massively oversimplifying here, but it took me a while to figure this out for myself. I never saw this explained anywhere else, so I thought I would do it. Let me go back to that first one. The user makes a request to the model runs inference based on the training that it has internally, and then generates the response. Sometimes you might make a request to a model, and it can infer to itself, based on its instructions, that it can't answer the question. You've asked a question like, when is the next F1 race? And that information wasn't present when the model was trained. So it knows that it can make a tool call. So it makes a tool call, goes out to the web, does a search. That search returns data, processes that data, runs some more inference, and comes back to you with a response. And that's why you can ask it to write me a poem about trees, and it can just infer that and come back to you. Or you can ask it like legitimate questions, like go search the web and go and find a best product. When is the next F1 race? Who won the last race? I'm a little F1 obsessed. That's okay. But these tools don't have to just be search. They can actually take action. And so that's what you experience when you ask ChatGPT to go and build your PowerPoint deck, or run another command, or how the CLI tools can scrape your code base and answer questions about your code base. They are understanding that request, going out and calling the right tool, processing that data, and then coming back with a response. So it's not magic, it's a machine. It feels like magic. And when you combine a model with those instructions, give it the ability to call tools, and give it some context or memory so it can kind of keep track over time, that's what's referred to as an agent. Next, I want to talk about what it feels like when you start using these tools to actually go and build something. And for me, my adventure started with a really simple question. I asked one of these agents models, hey, is it possible to make a ChatGPT client for Apple Watch? Kind of technical question, not something I felt like Googling and hunting around for. It was just a kind of spur-of-the-moment thing. And it came back with code that actually compiled and ran, like very, very quickly. And so what I experienced was that with the help of AI, it really collapsed that first stage of exploration to next to nothing. It collapsed the feasibility question and it changed it from, is this even possible, to, yeah, it runs, which was super exciting. But what it then immediately brought me to was the next question along the journey, which is, okay, if it's possible, what should this actually be? And what should it actually do? And the bottleneck isn't code when you ask these questions. It's judgment. You get into questions of, what do I want to build? What would be useful? And it became really practical for me. Like, the watch isn't a very common platform to develop for. There's not a lot of resources out there to answer your questions. There's not a lot of guidance in terms of how things should be done. You kind of have to make it up as you go. There's lots of resources on Apple's Dub videos in terms of design guidance and so forth, but they don't really answer the question of what should I build and how should I build it. So AI made the exploration faster, but it definitely couldn't tell me if it was worth building. And that shift is now coming back, and it's being reflected in our tools as well. So this is a screenshot of Cursor. And AI first started to get introduced into IDEs, into Xcode 26.3 as a chat in the sidebar that allows you to operate on your code in the center. But as these agentic IDEs are evolving, the priorities are also changing. So here you can see that on the left, where you used to have your file browser, you now have your list of conversations with your agent or multiple agents. In the center, code isn't primary. It's actually the chat and the conversation that you're having, and the plan that you're building over on the right. In fact, your file browser, your Git history tree, they're optional panels way over here on the right, which you can pull out and glimpse at when you need to. But they're not really the primary way to interface with code bases in this new mode. And so this is a very common pattern, discovery through coding, and it's how we operate today. We look at a problem, we start to form the shape of the solution in our head, we write some code, we start exploring. And the shared understanding typically emerges a little later through code reviews and checkpoints and when you pair program and so forth. And that's not new, and it's certainly not inherently wrong, but the point is that it scales less well when you start collaborating with another entity, whether it's an agent or a teammate. So the answer is not to stop exploring by any means, but to get to shared understanding sooner. So you can explore fast, yes, but don't let AI generation outrun alignment and understanding of the thing that you're building. What we do as engineers comprises so much more than code generation. When we hear that AI is going to take our jobs and look, I can click a button and get an app out the other end. And as you think about the things that we do as engineers, as developers, higher up the stack, these are things that are increasingly difficult to automate. So code generation, verification, sure. But when you're thinking through a problem and you're coding something, you're employing systems thinking. You're thinking about intent. What is the thing that I want to build? You're thinking about architecture. How can the whole system fit together? You're making trade-offs about the product that you want to build. Trade-offs is an interesting one. I want to call that out because in order to kind of consider a trade-off as individuals, that is a kind of a negative, it involves negative thinking. You have to think of what the thing is that you want to avoid. And AI, I'll say, can't help us there yet, although it's very good farther down the stack. So the story isn't that engineering matters less just because some of these items are heading towards automation or becoming a lot faster. It's just that more of what we do day to day is now in view. So I'd like to put to you that AI doesn't actually make engineering any less important, and it just makes bad engineering cheaper. So this is the point I want to leave you with. To get started, applying some of this thinking in your day-to-day. The faster generation doesn't remove the need for judgment, but it raises the premium on clarity, coordination, and taste. So some takeaways for Friday morning, for Monday morning. Use these tools. Experience the sheer joy of speed running all the hard bits at the beginning of a journey. And then come back and bring that alignment to your colleagues, to your teammates, and to the products that you're building. You can use AI to accelerate thinking. I wonder what if, get the answer. Not to avoid it, right? And I encourage you to move your attention further up the stack. Your expertise is always going to be useful to validate and judge the output of the AI. Is this really what I want? Is this going to work? Is this the right trade-off to produce the product that I want to make? But yeah, essentially, take that perspective. If any of this has been useful to you, I would love to continue the conversation. So please get in touch, and I'd love to hear from you.